Alright, so for number 13, we need to graph this function without using a calculator. So notice that this has an a value to it, this multiplier in the front. Anytime there's an a value, if I were you, I would make a 3-column chart. So here's what I mean. First of all, okay, so I'm making this nice and big. Alright, so here we go. Make this a little bit smaller. Alright, so my x's, of course, we're going to go ahead and use our -2. Alright, our -1, our 0, 1, and 2. Alright, so the first thing you should do is make a column for your parent function. Okay, so my parent function, which I'm just going to label it b to the x power, alright? But in this case, of course, it's 2 to the x power, alright? This is the parent function that I am talking about. And that's what I'm going to put first. So if I do 2 to the x power, in other words, 2 to the -2 power, 2 to the -1 power, 2 to the 0 power, 2 to the 1 power, and 2 to the 2 power, like we've seen many times, we're going to get 1/4, 1/2, 1, 2, and 4. Alright? I'm going through this kind of quickly because we've done it so many times now, but I'll just do this 1 just in case you're not seeing where the 1/4 is coming from. 2 to the -2 power, that negative power drops you down, so that's like 1 over 2 squared, so that is 1/4, and so on. Okay, so that is your first column, but that is just the parent function. Okay, next in the third column, I would go ahead and apply the a value, which in this case is -4. So I will call this my a b to the x power column because I'm applying the a term. Alright, so look, my a term is that I'm going to multiply everything by -4. So that means I'm just multiplying this by -4 and this. Everything is getting multiplied by -4 because that's my a value. Alright, if I do that, this is going to become -1. Alright, I'm only going to show this a couple of times, but look, -4 times 1/4, that's -4 times 1/4. Okay, the -4 is like -4 over 1. When you multiply, you just do numerator times numerator, denominator times denominator. So that's why this will be -4 over +4, and that's why you get -1. Alright, so similarly, I'm going to get -2 for this one. Alright, I'm going to do this one more time. So -4 times 1/2. Well, this is like -4 over 1 times 1/2. So this is like -4 over 2. You multiply straight across. -4 divided by 2 is -2. That's where the -2 is coming from. The rest of these are obvious. So this will be -4 and -8 and -16. Okay? So these are the values that we're actually going to graph. Alright? Because that represents the entire function. Let me clean this up. Alright, we know the asymptote is going to be right at 0 since there's nothing being added here onto the end. So let's go ahead and draw the asymptote. Okay, so here we go. So at -2, we are at -1. So that's just going to be right here. Alright, and then at -1, we're at -2. And then at 0, we fall to -4. And then we'll have -8 and -16. So we have -8. And of course, -16 would be way off the chart somewhere. I could probably fake it. Alright, 11, 12, 13, 14, 15. It'd be like somewhere down there. Bottom line, when you get these graphs going way off the chart, you can just use the ones that fit. So let's go ahead and draw the curve, and for this problem we will be done. So you see, because of the negative value in front, this was in fact reflected over the x-axis, so that's why it's all upside down and stuff. Okay, that got a little crazy there at the end. I'll just pretend that was an arrow. Okay, bam. The graph should be looking something like this. And that's how you do that. It's all about the triple graph. Let me zoom out a little bit. Alright, it's all about having the triple table. That is the key to graphing these. Okay, so let's go ahead and do number 14. Alright, this one even has a shift on the end of it. So that's going to be one extra step, so I can't wait to do that. Alright, let's go ahead and make our triple table first. So, okay, here we go. I'm just leaving room for 3. And so here we go. So this will be my x column. So here we go. -2, -1, 0, 1, and 2. Now, first we just do the parent function. So this will be the column for my b to the x power. Alright, I see that there's an a value, so I am going to leave room for a third column where then I will do my a times b to the x power. So we're going to have to do a triple column anytime there's an a value. But let's start with the parent function. Okay, so remember, I'm doing 4. When I say the parent function is 4 to the x power, okay? So that means 4 to the -2 power, 4 to the -1 power, 4 to the 0 power, 4 to the 1 power, and 4 squared. So this is going to be 1 over 4 squared, which is 1 over 16. This is just 1 over 4. This is 1, this is 4, and this is 16. Okay, so I'm just going to copy this down. So we have here 1/16 and 1, you know what, let me leave extra space here. Okay, we have 1/16, we have 1/4, okay, we have 1, we have 4, and we have 16. Alright, this is not the final answer, but this is the parent function 4 to the x power. Next, we will apply the a value, the multiplier that's in the front. Okay, let me just delete some stuff. Okay, so the multiplier is 1/2. So that means I'm just going to take everything and I'm going to multiply it by 1/2. Alright, if I do that, 1/2 times 1/16, that's 1 over 32. Alright, this is 1/8. Alright, this is just 1/2. Half of 4 is 2, and half of 16 is 8. So I've got this. So you can see this is a vertical compression. You can see these values getting shorter than they were. Okay? Now, this is not the final answer because of the +2. But if I were you, I would go ahead and graph this. Once you apply the a value, go ahead and graph the skeleton of it, graph these 5 values, and then we'll do whatever shifting we need to do after that. Alright, so here I have graphed the skeleton here, the 1 over 32, which is pretty much on the line. 1/8 is also so close to 0, it's going to appear to be on the line. 1/2, well, that's half a square up. And then, of course, 2 and 8. That's the skeleton. That is not the answer because we have not applied the shift up 2 yet. So what I would do is I'm just going to change colors. And I will just take each of these points and shift them up 2. So this point would be here, this point would be here, this point would be here. Alright, up 2 and up 2. So these green dots show my final answer. So I will actually draw the curve there. Let's get the asymptote going though. We know the asymptote was at 0 before the shift. So since we're shifting up 2, the asymptote will shift up 2 as well. So this is where the asymptote will be. Plus we know if there's a 2 is in the k spot, then the asymptote is going to be y equals 2. Alright, so all that's left is to go ahead and draw this curve. Now all the rest of these points are going to be so close to 0 that they will appear to be on the line. So just go ahead and sort of trace along, but in your mind know that it's not really touching. It just looks like it's touching. Alright, and just keep going as best you can. Alright, I'm messing up a little. Let's see if I can connect it up. Alright, I'm not really trying to hit that point right there. That was just a coincidence. Okay, so your graph should look something like this. I'm going to clean this up a little bit. Your graph should look something like this. Number 15. As soon as we see that there is an A value of 3, I know I'm going to need a 3-column chart. So let us begin, my friends. Okay, that should be enough for 3 columns. Alright, this should do it. So there's our first column with the usual values, -2 down to +2. Now, in the second column, we will just do the parent function. Please understand that the parent function is just this. It's 1/4 to the x power. Alright, so I will just put b to the x power to remind me that we are doing the parent function right now. Okay, so if I were doing that, then that means I would have to do 1/4 to the -2 power and 1/4 to the -1 power and 1/4 to the 0 power and 1/4 to the 1 power and 1/4 to the 2nd power. Don't forget, if you have a fraction with a negative power, you do the reciprocal. So this is just going to become 4 to the +2 power. 4 squared is 16. Alright, so this will be 16. Again, 1/4 to the -1 power, do the reciprocal, so that's just 4 to the +1 power, which is just 4. Anything to the 0 power is 1, so kabam. 1/4 to the 1 power is just 1/4. And 1/4 squared, well, 1 squared is 1, 4 squared is 16, so 1 over 16. Okay, so we did that. Now it's time to apply the A value. So that's why I will call this my A times b to the x term. Alright, let me clean this up. Okay, so since I'm going to apply the A value, in this case, that means multiplying everything by 3. Alright, so that's what I'm going to do. I'm just going to do 3 times this, 3 times that, 3 times this, 3 times that, and 3 times this. 3 times 16 is 48, which is going to be too big for my chart, but what are you going to do? 3 times 4 is 12. 3 times 1, of course, is 3. 3 times 1/4 is just 3/4. And, you know, which, if you need it, is the same thing as 0.75. And 3 times 1/16 is just 3/16, which, by the way, 3/16, that's 0.18, that's basically 0.2. Okay, so this is not the final answer, because what we haven't done yet is the -5, which will shift everything to the right 5. But this is where we will graph first. The idea will be to graph these 5 points, just the dots, and then shift them all to the right 5 and draw the graph. All right, so let's go ahead and graph the skeleton. At -2, we have 48. All right, so that's way off the chart, so I'm just not even going to deal with it. At -1, we're at 12. That's a little bit off the chart, but I'm going to go ahead and fake it. So so at -1, we're at 12. So this is like 11, 12. It would be right about here. Okay, and then at 0, we're at 3. Okay, and then next we're at 0.75, right? That's 3/4 of the way up, so that's about here. And then finally at 2, we're at 0.2, okay, which is like 1/5. So that's basically practically on the line. So these are the 4 points that we can get onto our graph. This is the skeleton. This is AB to the x. We haven't done the -5 yet. Let's do that now. So the -5, again, that is just going to shift everything to the right by 5. So if I were you, I would just do that on the graph. I would not mess with the table and make another table. Just shift everything to the right 5. So if I do that, all right, this is going to be over 1, 2, 3, 4, 5. Would be like here. Okay, same thing. 5 over. And 5 over. All right, so these green dots represent the actual function that we're going to be graphing. Let's get the asymptote in here and draw this graph. Okay, so there's the asymptote. We did not shift up or down, so the asymptote is still at 0. All right, so on the right-hand side, it's going to appear to trace, but we know it doesn't really touch. In our minds, we know this. Okay, so far so good. This is the difficult part. All right, so basically there you go. So that is your graph. We're done with number 15. Any questions? Yeah, talk to me later. All right, so number 16. Once again, we see that we have an A value in the front, all right, this 1/5, which, by the way, will be a vertical compression by a factor of 5, should be like squashed. That if there's an A value, we will need the 3-column chart. So let's just get started making our 3-column chart. All right, about that big should do it. So there's our good old X values. Okay, and So now let's just do the parent function, all right, just the b to the x. So I'm talking about 1/2, to the x power. So I'll be doing 1/2 to the -2 power, 1/2 to the -1 power, 1/2 to the 0 power, 1/2 to the 1 power, and 1/2 to the 2nd power. Don't forget to do your reciprocal. So this will become 2. All right, the reciprocal of 1/2 is 2. So this will become 2 squared, which is 4. Reciprocal, sorry, I don't know where that 1 came from. The reciprocal, again, is 2. So this will be like 2 to the 1 power, which is just 2. Anything to the 0 power is just 1. 1/2 to the 1 power is just 1/2. And 1/2 squared, well, 1 squared is 1, and 2 squared is 4. So there you go. Now, we need to do this multiplying by a business. So that's what I'm going to do. All right, and that's what I'm going to put here. This will be my a times b to the x power. So I'm just going to multiply everything by 1/5. Okay, so I'm just doing 1/5 times this. 1/5 times everything. Okay, well, this is just going to be 4/5, which is 0.8. This is just 1/5, which is 0.2. This is going to be 1/10. I don't even need the 0.2. All right, I mean 1/5, that's a fifth of a square. All right, that's easy enough to graph. 1/10 is a tenth of a square. All right, and this is going to be 1/20th. It's 1/20th of a square. All right, so these are easy enough to understand the way they are. Wait, hold on. I put this in the wrong spot, didn't I? 4/5 was 0.8. Okay, now 1/5 times 2, that is 2/5. All right, and 2/5 is 0.4. Okay, so these are a lot of really small numbers. Hey, we're just going to do the best we can. All right, it's time to go ahead and graph this skeleton. So at -2, all right, we're at 0.8, which is like almost 1, but not quite. At -1, we're at 0.4. That's a little bit below 0.5, so just a little bit below the middle. At 0, we're at 1/5, which is like almost on the line. And by the time we get to 1, we're at 1/10. All right, 1/10 is so tiny that it's going to pretty much just appear to be on the line. Okay, same with 1/20th. All right, really tiny. Okay, fine. So that is the skeleton. That's a very squished graph. But we still have to do the transformation. So let's go ahead and do the transformations now. The two transformations are, because of the +1 in the exponent, that means we have to go left 1. Okay, because of this -2, that means we have to go down 2. So everything's going to go left 1 and down 2. All right, let's start with this. If I go left 1, okay, and down 2. All right, so that'd be 1, 2. So that'd be like right about here. Now the rest of these I can just follow the pattern. Okay, so the next one over is like here. The next one over is like here, and then the last two the last two are like virtually on the line. Okay, so I just moved everything left 1 and down 2. All right, so this is the actual graph. Let's just go ahead and obviously the asymptote has moved down to -2 as we knew it would be because of the -2 right there. Let's just graph it up. All right, so there's the asymptote right there. And these points are already looking like they're on the line, so you know the entire rest of the curve is going to basically appear to be on the line here. So I will just draw this tracing motion until here it begins to rise up, and then it will just sort of continue its curvy rise for the rest of the situation. All right, so your graph would look something like that. So that was number, whatever it was just now. That was number 16. Okay, let's go ahead and do number 17. Okay, once again, I see the A value staring me in the face. That means I need to do a 3-column chart. Alright, so here I've started my 3-column chart. In the first column, I just do the parent function, b to the x power, which in this case, the parent function is 3 to the x power, which just means I'm doing 3 to the -2 power, which would be 1 over 3 squared, which would be 1 over 9. Alright, and I'm doing 3 to the -1 power, which of course would just be 1/3. I know 3 to the 0 power is 1. If I do 3 to the 1 power, that's just 3. And if I do 3 to the 2nd power, that is 9. Okay, so this is my parent function. Now, for my 3rd column, I will apply the A. In other words, I will multiply everything by -2. All right, so I'm just going to do this, -2 times everything. Okay. So if I do that, I'm just multiplying by the numerator, okay? So this will become -2/9, which as a decimal, okay, -2/9 is basically 0.2. So equals -0.2. And then this is going to be -2/3, which equals -0.7 about. And of course this will just be -2 and -6 and -18. So these are the values we must graph. Let's see, can I move this over? No. Good enough. All right, let's go ahead and graph the skeleton. So at -2, we're at -0.2. So that's going to be just a little bit underneath the line. At -1, we're at -0.7. Okay, that's more than halfway down. At 0, we're at -2. At 1, we're down to -6. After that, it goes to -18, which is really it's too far off the chart for me to mess with. So I'm just going to work with these 4 points that we've got so far. This is my skeleton. Now, to get my actual answer, I still need to do the transformations here. I need to do the +1 and the other +1. So please understand that this +1 is going to send us to the left 1. Okay, whereas this plus 1 is going to send us up 1. All right, remember this is sort of the opposite of what you would normally think, so left 1 and up 1. So I just need to take these 4 points and I'm going to move them left 1, up 1. Okay, so here I go. Starting with this point, if I go left 1 and up 1, it would be right here. All right, again, left 1, up 1. Okay, left 1, up 1, left 1, up 1. So the green dots represent the actual curve. You can see that the asymptote needs to be at positive 1. So let's go ahead and put that in. Okay, so there's the asymptote at positive 1. And now we will just draw our curve as best we can using the green dots. So it's approaching the asymptote here on the left. So it's already so close. So by the time it's over here, it's going to basically appear to be tracing the line, even though in our minds we know it is not. And then it will curve down like this. All right, and it will continue to curve like this. Okay, so not the prettiest graph in the world, but you get the idea. And that's it. That is how you would graph that problem. Okay, so that was number 17. Last one, I think this is the last one. Number 18. One more again, boss. Once again, you see that we have an A value. Anytime we have an A value, this extra number in the front of the base, plan on making a 3-column chart. Let's do that now. All right, so here's my 3-column chart ready to go. First, we need to do the parent function, b to the x power, which in this case is 1/3 to the x power. All right, so that means I'm going to be doing 1/3 to the -2 power, 1/3 to the -1 power, 1/3 to the 0 power, 1/3 to the 1 power, and 1/3 squared. When you have a fraction with a negative power, you do the reciprocal. The reciprocal of 1/3 is 3. And then I'll have a positive 2 power, which is 9. Kabam. Negative power, do the reciprocal. It is 3. 3 to the 1 power is just 3. Anything to the 0 power is 1. Right? 1/3 to the 1 power is just 1/3. And 1/3 squared, 1 squared is 1. 3 squared is 9. So 1/3 squared is 1/9. So there you go. Now it is time to do the third column where we do a times b to the x power. So we multiply everything by the a value, which in this case is -1/3. So I am going to take this and multiply it by a -1/3. And I'm going to do that to every term. All right, so that is going to give me, look, 9/3 is 3. So this is just going to give me -3. 3/3 is 1, so this is going to give me -1. Okay, and now we'll just have -1/3 because I'm just multiplying by 1. This is going to give me -1/9. All right, because 3 times 3 is 9. And this is going to give me -1/27. All right, 3 times 9 is 27. So these are the values that I will actually graph as my skeleton. All right, so at -2, we're at -3. Easy enough. Okay, at -1, we're at -1. Okay, so -1, -1. At 0, we're at -1/3. All right, it's about there, a third of the way down. Now at 1, we're at 1/9. All right, this is getting into that area where it's starting to look like it's almost right on the line because it's so small. Once I get down to -1/27, that is so close to 0 that you pretty much just have to put it on the line. So that's your skeleton. Now, don't forget, we still have not done these other two transformations, the shifts. So let's do that now. So this tells us that it's going to be left 3. And this tells us that it's going to be up 4. Okay, so we have to shift left 3, up 4 from here. So I'm going to take each of these and go left 3, up 4. Okay, so let's start with this one. Left 3, up 4. That would be right here. If I did the same thing with the next one, I can kind of already see that it's going to end up right here. Okay, if I do the same thing with the next one, it's going to be about right here. Okay, if I do the same thing with the next one, right, it's about right there. And that last one is going to be right about there. I have taken this graph that didn't have the shift in it, and I took all 5 of these points and I shifted them left 3 and up 4. So that means I'm ready to actually graph it. Of course, the asymptote is going to be up here at 4, so let's go ahead and draw that. Okay, so there's the asymptote. And now we can go ahead and draw the actual curve through these green dots as best we can. Whoa, I didn't mean to do that. Let's see, green dots. Okay, by the time I get over her, it's going to appear to be just tracing this line. So by the time I get over here, it's going to be doing like this. All right, then it's going to be curving away like this. Oh man, I messed that up. Let me try one more time. This is hard to do with an electronic pen. All right, it's a little squiggly in there, but that's about as good as I can do. All right, so there you go. That's it. That is how you graph a function, an exponential function, that has all the goodies in it. All right, it has the multiplying by a part. It has the shifting up, down, left, and right. It's all about doing a 3-column chart. Do your parent function, then apply your a value, graph the skeleton, and then do your shifting last. Up, down, left, or right, and then you're golden. I'm pretty sure that is it for this assignment. Let me just zoom out real quick. Make sure nothing's sneaking through the cracks. All right. Yep, guys, I think we're done. All right, I hope this has been helpful to you, and I will see you on the next video.